Thank you. My name is Ian Cook. I'm with Cloudera. Cloudera is a leading provider of open source big data storage and processing software. You may know of us as one of the original companies to commercialize and popularize the Hadoop framework. Today we offer a platform that includes a whole host of tools that enable customers to store, process, query, search, petabyte scale data across distributed clusters and also stored in cloud services. So today I'll briefly talk about a package I made to help dplyr users seamlessly use one of these tools called Impala. And then I'm going to also talk more generally about some advice that I have if you should want to do something like this to contribute to dplyr and dbplyr to make it work better with a particular underlying SQL database. So one of the tools in our platform is Apache Impala. So Impala has been around for a few years. Does anyone raise your hand if you've heard of it? Okay, and if you've used it? Okay, oh wow, quite a few folks, okay. So I'll briefly describe it here. It's a massively parallel processing query engine. It enables low latency SQL queries on data stored in a variety of systems. Originally it was just HDFS, the Hadoop file system. Now it's also a bunch of other things, including S3. It's great for interactive use because of its low latency. It returns query results very fast. Typically, it can be in sub-second time. Basically, what Impala does is it turns enormous data sets in one or more of these systems into a fast, efficient, modern analytic database of almost unlimited scale. It accepts SQL queries much like any other database. And Cloudera created this and then released it under the Apache open source license and donated it to the Apache Software Foundation, where it's in the incubator there. There are some comparisons I could make to other database systems and things like Hive. I'll skip that for now in the interest of time, but if you have questions, happy to answer those. So recently, Cloudera has become more focused on creating a better experience for data scientists using our platform. Most often, this means people using R and Python. On the R front, we've done a number of things. We've partnered with RStudio. We've embraced Sparkly R to give our users better access to Spark on our platform. We've also released a tool called Cloudera Data Science Workbench, which is a web browser-based tool that allows data scientists. It provides them with isolated R and Python environments that sit alongside the cluster where the data and the compute happens. This helps eliminate a lot of the woes of self-service access, authentication, governance, all this. And that uses Docker and Kubernetes. And my contribution here to this effort has been to create this implyr package. So I'll talk a little bit about that. But so implyr is a SQL backend for Impala. Basically, it's a layer between dplyr and Impala that makes the two work better together. And I'm going to jump into a demo, which probably won't work, but I have screenshots as a backup. I'll open up this data science workbench environment here. If I could find my pointer. Okay. So the implyr package is on CRAN and GitHub, so you can install it using those commands. Right. And then you can connect. Let me see if this actually works. Oh, wow. Okay, so you can connect using this src_impala function. To this you pass a driver, a DBI compliant driver, like Jim's ODBC package is the one we're using here. That's the one I recommend. And you pass information including the host and port. And you could use keyring to pass the credentials and so forth. And then you instantiate this table object through the TBL function. You pass it the Impala connection object and the name of the table you're looking for. In this case, it's the NYC Flights 13 flights table. And then you've got a lazy tibble, this object that you can pass. You can use it as a table with all the dplyr verbs, just as if it was a data frame in memory, or as if you were using a Sparkly R or SQL Server or any of these databases. So if this demo right here looks familiar, it's because it's exactly the same one that you may have seen on the Sparkly R website. I mean, the point is just that the grammar is all the same once you make the connection. And there are a bunch of other demonstrations that are in the README, which you can find on GitHub or on CRAN. Okay, so yeah, so what's happening under the hood here is, again, Jim showed this, is that essentially all of these operations are being converted into SQL, which is then running, here's the query. Oops, that's not helping. Okay, here's the query you can see there, and then that runs on Impala and returns the result to R. Okay, so yeah, I cannot take much of the credit for how this works. Most of that credit belongs to the dplyr team, Hadley and Kirill, who spoke before, and Lionel Henry and others. They have created this awesome framework that does the vast majority of the work of allowing the dplyr to interface with almost any source that uses SQL as its query language. But implyr and backends like it can play an important role. Without backends, occasionally databases have their quirks and things can go wrong without them. So I'm just going to talk a little bit more about the role of backends, and specifically this one. And let's look at the whole stack sort of that sits between dplyr and the database. Kirill presented sort of one part of this. This is a sort of higher level view. So of course the user front end is dplyr. Under that, you've got this dbplyr package, which Hadley and others created by tearing all of the database functionality out of dplyr and making a simple, more maintainable, smaller package. Underneath that, you can have the SQL backend packages, implyr being one of them. Under that, you've got DBI, of course, which Kirill spoke to us about. Under that, you've got the DBI-compatible interface package, like ODBC, which Jim talked about. And then under that, you've got a driver or some sort of connector. In this case, it's the ODBC driver for Impala, which you can download from Cloudera or get from other sources and install. And then finally, you've got the database. So it's not strictly necessary to have this piece, and Jim talked about this. The whole stack can work without that one piece, but implyr and other backend packages like it, they can solve a last mile problem, where dbplyr gets you almost all the way there, but it can't solve all the idiosyncrasies of every different database. Every database has its own slightly different, or sometimes very different, dialect of SQL. It has functions it supports and doesn't support. It has methods for connecting to it, and it may have some nasty pitfalls. And as Jim said, some databases work fine out of the box, but that's not always the case. And if there is a problem, like using dplyr with your database, you might not discover it right away. It may only occur in some unusual situation, or it might be like an insidious problem that you don't realize until you start getting incorrect results. These are some of the things I found when I was exploring dplyr with Impala. So backend packages like this can still have an important role to play. And I think there are some other databases too where dbplyr could use some more help getting that last mile. So for the rest of the talk, I'll speak more generally about dplyr backend packages, and I'll share some tips based on what I've learned so far creating implyr. I'm not going to walk through all the technical steps of creating a SQL backend package because it would take too long and be really boring, more suited for a tutorial. But I'll introduce some higher level principles that I think will help. So the first thing is determine whether it's actually necessary to make a dbplyr or dplyr SQL backend package. As I said, it's not strictly necessary to make dplyr work with a given database. With some of the improvements in DBI, ODBC, and dbplyr, dplyr, as Jim said, can now automatically detect what kind of database you're using and even apply some different SQL translations depending upon that. So it may not be worthwhile to make a whole backend package if it's just that your database's SQL dialect has a few functions that aren't translating properly. You may be able to resolve that better by making a small contribution to dbplyr. There might also be some existing dplyr SQL backend package that you can contribute to, so you need to do some research. But in other cases, the only good way to support your database is by making a new dplyr backend package. Like if it uses a really profoundly different syntax than the typical relational database, or if it has some notable limitation compared to typical relational database. In the case of Impala, there were several good reasons to do this. I'm not going to go into a lot of detail, but I can talk about that later if you'd like. So if you do decide to go for it and build one of these packages, good for you. Stick it out. It may not be easy. Making a package like this is not a big project at all. It's likely just a few hundred lines of code. But because the code is interacting with all those different packages and also ultimately with your database, it can be hard. You may need to ask for help. You may end up asking a question that you fear gives away that you know nothing. I have done that a lot. Just yesterday in a GitHub comment thread, Kirill and Hadley were schooling me on not having my vocabulary right about Tibbles. They're very kind, but I feel like an idiot, and it's kind of embarrassing. So you need to have a thick skin, but also be polite, if you're going to enter this whole ecosystem. Hadley probably has better things to do than help you with your little pet project. So you may feel imposter syndrome at the beginning, but it gets better. You learn. Another thing you need to do is really know the database inside and out and its flavor of SQL. You need to know all its idiosyncrasies. Nasty mistakes are a lot more likely to happen when you don't understand how the database you're working with works. This is not meant to intimidate everyone. You can learn it. Just don't try to undertake a project like this without a plan to understand the database really well. You also need to know dplyr inside and out. This is made a lot simpler by the extraction of all that database code from dplyr into dbplyr. It's something you can sort of figure out. Knowing how dbplyr works intimately will help you troubleshoot problems. It's complicated. The best tip I can give here is to go to the dbplyr project on GitHub, fork it, clone the repo to your computer, open it in RStudio, build it, and then set breakpoints in places in the code where you don't understand what's going on, and run the code. And when it stops at the breakpoints, look at the local variables, step through. That really helps. Another important thing is stay idiomatic or stay tidy. The nice, clean, idiomatic syntax is very much the whole point of dplyr. To begin with, dplyr and the tidyverse have replaced a bunch of inconsistent ways of doing things with one clean, standard way of doing things. Don't introduce bizarre new conventions if you're going to do something like this. Nobody wants that. Very important, create automated tests. Once you have your SQL backend package coded up, but before you release it, you should write tests using testthat and other helper packages. Ultimately, you should have many more lines of test code than you actually have package code. The tests should run against some instance of this database, real live instance of this database that's accessible to you. You need to make sure, though, that these tests are skipped if it's running on an environment that doesn't have access to that database. So if you submit your package to CRAN, it needs to skip all those tests if CRAN does not have access to this database to actually do live testing. To do this automated testing, there's some tools available. Of course, there's testthat and so forth, but there's a nice package from Edgar Ruiz at RStudio called dbtest. dbtest, I think. There's a couple of them, right? Not DBI test, dbtest. It's on GitHub, I think, at rstudio/dbtest, and that can help you with some parts of this, understanding what you need to cover in your backend package. Building on that last point, it really helps to run a dedicated external instance of the database just for testing purposes. So it's a real problem if you are the only person who can run your test code. You really want to be able to use continuous integration like Travis CI to test each commit that you make to your repository. If you're using some big complex database or some proprietary commercial database or database that cloud native database, you probably can't just tell Travis CI to apt-get install your database and populate it with data each time it runs. So you may need to launch a persistent external instance of the database running on EC2 or the like. You can secure it, use environment variables to connect the CI app to it. And someone may need to pay for this. In this case, Cloudera does. This is also really necessary for getting contributions from others. If someone makes a pull request, you can see what they changed if it messed up any of the tests. You should, if possible, support multiple ways of connecting to the database. It's best not to create artificial limitations for your users. If your database supports like ODBC and JDBC, it's best to allow both. Although there are some problems with the RJDBC package right now that's maintained by Simon Urbanek. I think it's in dire need of some changes to make it truly DBI compatible. So like I really prefer ODBC for this, but some people want to use JDBC because it's harder to set up ODBC in some environments. So you need to evolve with dplyr and dplyr and the other packages in this stack. They change a lot. Breaking changes are not infrequent. Maybe they won't change as much in the future, but I would not place any bets on that. You should watch dplyr on GitHub, see the commits. Like just in recent weeks, Hadley changed something that broke implyr, and I had to fix it. And finally, you'll want to stay on top of developments in the database too. Most modern databases regularly add features, new built-in functions, and so on. I think this is a more accurate visual portrayal of what this evolution looks like. It never ends. And you will learn an immense amount and have fun, and maybe you'll give a talk at useR as well. Thank you.
Questions for Ian?
Hi, I'm an Impala user, and one of the things I really don't like is the multiple select distinct that you can't do. How do you manage that with implyr? If you do a distinct in R, if you do a distinct with two variables, does that crash? What does it do?
I would need to develop some tests for that, actually. That's a good point. So one of the things I like to do is note things like that, make a test that documents it, and then if it fails, just add a skip in there, but at least then I know that there's a test that ideally would pass. I'm not sure. I mean, I know you can do like a single distinct, and there's also window functions, which is often a workaround for that sort of thing, and this does fully support the SQL window functions, but I'd be happy to talk to you and see if it is able to solve, maybe in some indirect way, the problem that you're talking about. Yeah.
Thank you.
Any more questions?
Is there bulk load functionality in the package?
What's that?
Bulk loading, so when you have a lot of data and you want to push it into Impala.
Yeah, so Impala and all these Hadoop databases, they don't work the same as like relational databases with inserts and updates, but you can take data from a query that you've constructed, and instead of like computing it and returning the result to R, you can create a new table out of it. If you're taking data from R, though, and you're trying to put like a large amount of data into like one of those storage systems, this is not the best solution. You should come up, like I explicitly did not try to attempt to do that here because there's a whole bunch of tooling around like HDFS and all those other tools. There's not one place that you would like insert data to. It's any of these different systems, and Impala and Hive, for that matter, don't manage all of the inserts. So there's some, I'd be happy to answer specific questions, but not full insert capability, some of it.
Any more questions?
Does creating tables from implyr also communicate with HBase, so storing metadata?
Yeah, currently the create table method assumes that you're going to use HDFS, but it would be fairly straightforward to add parameters so that you could, insert data in other locations as long as Impala supports that. That's a good area of future development. And yeah, again, if you come talk to me, I'd be interested to hear more about your use case and see if the package can do it.
Final questions? No? All right. Thank you all for coming.